About to get started. Last call to take your seats. We'll be beginning any second now. All right, let's begin. Welcome, everyone, to the groundbreaking of Pacific Fusion's demonstration system. You can clap, you can clap. It is so fantastic to have you here on this very special day. We are humbled and honored to have so many people across federal government, national laboratories, state government, the private sector, and even friends and families of Pacific Fusion employees here. We really couldn't do this without you, and today is really about thanking you guys for all of the work that has gone into this moment and your continued support for fusion energy into the future. My name is Leland Ellison, and I'm the Vice President of Technology and one of the co-founders of Pacific Fusion. The demonstration system is intended to be the world's first net facility gain fusion driver. That is, it will extract more energy in fusion reactions than the entire system consumes in order to drive the fuel to those high densities and temperatures. This is a milestone that has never been achieved in the history of fusion and is the next major objective towards putting clean, abundant commercial fusion energy on the grid. Woo, yeah. We have a very exciting agenda today. We have a number of speakers this morning for this press conference to kick things off. We will then take a break for photographs. Speakers, please hang tight in the front and we'll coordinate going out to take photos and put shovels in the ground. Then starting around 11 o'clock, we'll have a Fusion Summit. This will take part in 2 different panels. We'll have a Fusion for Energy panel and a Fusion for Defense panel. And we have an incredible list of speakers for both of those, so I imagine you want to stick around for that. A couple administrative things. This is being streamed live, and there are microphones around the audience to capture the energy and the applause, but please reduce any conversations to a minimum and be mindful of your comments. And again, at the conclusion of this press conference, please hang tight for photos and we'll coordinate from there. So with that, let's begin with our speakers. Pacific Fusion is so proud to call Albuquerque home to its demonstration system. The city has been incredible at attracting the company here in the first place and enabling us to move so quickly, get tractors here and dirt moving already today. So with that, it is my pleasure to announce Albuquerque Mayor Tim Keller.
There we go. Good morning, Albuquerque. This is a wonderful occasion. Are we a little bit excited to be here? I think we are, right? A little bit of fusion in the room. So I want to share with you, I think, just really 2 things about how special this is for our city and our state. And as I think about, first and foremost, it's going to be a hot day, and that sun is shining bright. And sometimes, if you were ever in like 8th grade science class, you look up there and you're like, how does that thing work? And why can't it help power our city? Well, this is, of course, the basis of fusion. This is what fusion is all about. It's the power of the sun and harnessing that so that we can actually power everything that we do in so many ways. Now, that, of course, I'm talking about the sort of quantum chemical side of that. And as a scientist, I'm not going to go too much more into that except for this. You know, it's a rare occasion that our city has a chance to invest in a foundational technology. We know that we do a lot of good things, whether it is another sun-powered thing like solar, or it is investing in all sorts of different businesses that try and help employ our kids, bring our best and brightest home. And we do this across multiple industries. But rarely do we have a chance to actually invest in a foundational technology, something that has the potential to be transformative, something that we could actually be known for, not just throughout the country, but throughout the world. That is what Pacific Fusion represents for us. This is our chance to build the second chapter in our story of quantum technology, to actually say that this is a place that can help transform the world. Now, we know that our story starts back with our labs and our technology, and we'll hear a little bit about that. But this is about a whole new generation, a whole new calling of purpose, and a whole new way to honor the amazing things that science has actually given us in our lives and what it can give our kids in the future. And so for me, this is something that we don't always get to do. We love the jobs. We love the billion-dollar investment. We love all of those things because we need them in our city to power our economy. But we also need Pacific Fusion to power our lives. That's what this is about. This is a moment that hopefully is something we will remember long into the future, the time when Pacific Fusion started to actually do what they do right here in Albuquerque, New Mexico. Now, that promise is something that we start today by sticking that shovel in the ground. But there's something else that makes today special. Some of you may know that I'm basing my entire next term on this notion of abundance and pushing back on the scarcity mindset that I think has held us back for generations. And this is the first economic development project that I can point to that actually demonstrates that. And without going too far into it, it basically works like this. We have lots of legislators here, lots of folks in economic development. We know the State Investment Council manages the surpluses from our oil and gas funds, and they do a great job. They get us a good return, and that helps fund our schools. But how often do we get a chance to invest in ourselves, not just in out-of-state companies and things like this? That's also what this is. This is the first time that we have partnered with the State Investment Council to use our land grant permanent funds through their investments in private equity, which then invested in Pacific Fusion to say, please come back home to New Mexico. This is how it's supposed to work. This is how we can invest in ourselves in the future. And so that is also extremely powerful today. So I want to thank everyone who helped put this deal together on the back end and made all of that possible so that we can actually see the old-fashioned energy that we take out of the ground flow through our State Investment Council into the market and then back right here to New Mexico in new sustainable technology. So a round of applause to the Investment Council, everyone who put that together, all the investors who made this happen. Now, that brings us to introducing our next speaker, who is the personification of the story I just told you. He used to work at Sandia Labs. He has his own New Mexico story. He met his wife here, and he is now coming back to lead Pacific Fusion. Please welcome their CEO, Keith LeShern. Come on up.
Thank you so much. Thank you. All right. Thank you all for coming. Some great remarks. Thank you, Lee. Thank you, Mayor Keller. We have an amazing agenda today, so thank you all for coming. So today really marks a new beginning for Fusion in America. It's an extraordinary moment, not just for Pacific Fusion, but for the state of New Mexico and for the country. It's also really a celebration of the many people here, those watching online, and literally the thousands of people it's taken over decades to develop the fusion technologies that we now have a chance to build the next chapter for America. The fundamental purpose of what we're building is to break ground on a facility that's something that's never been done before. That's to produce more energy from the output of this fusion machine than goes into generating the fusion reactions in the first place. This is a big deal. This is a prerequisite for generating clean fusion power. And this is where it's going to be done first, right here at this site. Also has another very, very important use. It's designed to produce more than 10 times more output energy than today's leading laboratory facilities. And this is useful, gives scientists a way to recreate extreme environments that can be used for all kinds of applications, from material science to qualifying electronics and other defense applications. We're not building an incremental improvement here. This is a major step change, and it's a major step forward for the country. And this is at a time when China is investing heavily in fusion technologies for energy and defense. And so this represents a really exciting moment for us to stay ahead. If you take a step back, commercial fusion is today really where commercial space was 20 years ago. We had amazing technology, we had amazing national labs, but we needed fundamentally new models and government-industry partnerships to build that next chapter and create what is today a widely understood and known commercial space industry. You wouldn't know what SpaceX is today without the investments in government-industry partnerships 20 years ago. I want to make sure to recognize some special guests today. We have U.S. Senators Heinrich and Lujan here, Undersecretary Brandon Williams from the Department of Energy's National Nuclear Security Administration, Lieutenant Governor Howie Morales, and we have many, many other federal, state, and local partners, our national laboratories, public utilities, our investors, and everyone else here who's made this day possible. I want to make sure, most importantly, thank our amazing Pacific Fusion team, not only for this beautiful day, but for the many, many challenges. We've taken on one of the hardest engineering challenges there is, and this team has just come at it with extraordinary ambition, urgency, and determination. 3 years ago, Pacific Fusion was just an idea. Today, we're breaking ground right here at one of the fastest journeys from idea to groundbreaking in fusion history. It's just the first shovel, though. We're very mindful of that. This is the first shovel. We have a long way to go. Thank you for being here, and I hope you'll all return at the ribbon cutting in just a couple of years. Thank you very much. Look forward to introducing our next speaker, Senator Ben Ray Lujan. He's been a longtime supporter of clean energy in New Mexico's national laboratories and American scientific leadership. We appreciate his support for public-private partnerships that help turn great American science into great American industries. Please welcome Senator Ben Ray Lujan.
Thank you. Appreciate that. Thank you. Well, good morning, everyone. It's good to see you all. Looking good. I don't know about you all, but I got ready for today with a lot of sunscreen because I was not expecting a little bit of a canopy to keep us nice and cool here today. Well, I want to recognize Eric and Keith and the whole team here for making New Mexico home. I also want to recognize one of our colleagues who you'll hear from in just a moment, John Hickenlooper. Senator Hickenlooper is from Colorado. And Eric, you need to know that John Hickenlooper believes in you. When John and I got to talking about today, John said, you're not going to be anywhere else in New Mexico except to be here to celebrate what's happening. And, well, he didn't include some other words when he described to me how big of a deal this was. We often know how this gets described some days. And so the fact that the leadership who's here today, every one of you that have been a part of this, whether you cast a vote, you were part of a study, you helped turn dirt, you organized the workforce, thank you. While this doesn't just matter to us here in New Mexico and our state, as the mayor shared, this is for America, and it's global. This is game-changing. Now, every one of you that has ever been part of any conversation about moving an electron so that when we flip that switch or we turn on that terminal, the magic begins to happen, understands the complexity of what it means to move those electrons. But what I always appreciate is, with all these conversations we've had in America when it comes to power, once we depreciate assets and you start looking at making sure there's a return on building all that generation, you look to the fuel source. At a time when things are getting more and more expensive, how about getting to a place where that fuel source isn't costing much of anything once it's depreciated? And all of a sudden, electricity is abound, it's around, it's going to power the quantum workforce that we're building here. Yes, Senator Hickenlooper, in New Mexico, building the quantum workforce with what we're seeing right next door here in Mesa del Sol as well. Look, I'm so excited about what this means, not just for us here at home, for being an example across America, but around the world. To Pacific Fusion, I just can't thank you enough for making today possible. To our lab directors who are here as well. As New Mexico is slated to have the fastest computers in the world, again, it's going to take some power to make sure that we're able to take full advantage of the computations, of the success. And as I often say about our national labs, anytime something significant is happening around the world, if it's bad, someone from our national labs is there trying to figure out how to make it better. If there's a challenge somewhere, someone from our national labs is there trying to make sure that we're able to bring a solution forward as well. That's how we work together. So New Mexico Innovation, bringing the best and brightest. Pacific Fusion, welcome to the family. We look forward to doing more with you, and we will all be back for that ribbon cutting. Everyone, thanks for being here. Stay strong.
Thank you, Senator Lujan. Really appreciate the comments. So next, before we hear from Senator Hickenlooper, we have a treat of hearing some prepared remarks from Senator Dave McCormick of Pennsylvania. He unfortunately couldn't be here today, but he serves on the Senate Committee on Energy and Natural Resources and is a staunch advocate of advanced energy and the role of fusion in the nation's future. So he was kind enough to record a video, and let's listen to those remarks.
Hi, everyone. I'm sorry I couldn't be with you in Albuquerque today, but I'm grateful for the opportunity to join you as you celebrate this exciting milestone. Congratulations to Pacific Fusion, its employees and partners, our national laboratories, and everyone who helped make today's groundbreaking possible. This project represents America at its best. It brings together decades of groundbreaking research from our national labs with the innovation and entrepreneurial spirit of the private sector to build something that will strengthen our economy, create high-quality jobs, and help secure America's future. I'm a strong supporter of advanced nuclear technologies, and I'm especially excited by the promise of America's emerging fusion industry. The simple reality is that America needs much more energy. Artificial intelligence, advanced manufacturing, and the industries that will define the 21st century require abundant, reliable, and affordable power. As I often say, AI and energy are two sides of the same coin. If we're going to win the global race for AI and advanced manufacturing, we have to lead in energy. And fusion has the potential to provide abundant, scalable, clean energy, while also strengthening our national security. Facilities like Pacific Fusion's demonstration system will help move us closer to commercial fusion power, while advancing capabilities that are critical to our national defense. Projects like this also demonstrate the power of public-private partnerships. They show how America can take world-class scientific research and turn it into advanced manufacturing and build strategic capabilities right here at home. The competition with China is real, and the stakes couldn't be higher. America pioneered the path to fusion, and we cannot afford to lose our lead in this critical technology. That's why I'll continue working to support partnerships and investments that allow American innovation to succeed. Today's groundbreaking is proof that America can still build big, ambitious projects and build them here at home. Congratulations again to everyone at Pacific Fusion. I look forward to seeing all that this facility accomplishes as we strengthen America's energy future, national security, and economic leadership together. Thank you.
Fantastic. Next, we have the privilege of hearing from U.S. Senator John Hickenlooper. It is a special treat for me to introduce him. Colorado is, in fact, my home state, so I really appreciate you making the trip down to New Mexico, and he is the only peer-reviewed scientist serving on the Senate. So he's in good company today, and please welcome Senator Hickenlooper to the stage.
Thanks so much. On the pyramid of scientific relevance, geology is a little bit down in the pyramid relative to what we're talking about today. I think it's amazing to be here, and Keith and Eric, the team you've assembled, you're on the precipice of doing truly great stuff. And I look back, I looked up this last weekend. We discovered or cultivated, I can't say people discovered, but the humanoids first discovered and cultivated fire somewhere between 120,000 years ago and 900,000 years ago. Not a lot of data back there to make sure to get a precise measurement. We've been burning stuff all that time to get the vast majority of our needs met around energy. What we're seeing today is the transformational moment. This is something that 20 years from now, people are going to look back at and they're going to say, were you there in Albuquerque when they first turned the soil to make sure that this Pacific Fusion thing was going to get a chance? And you'll be able to say yes. And it's a function, and Ben Ray Lujan, who, despite his competitive words, is a good friend. Colorado and New Mexico are friends and allies. We compete with each other, but in the same way that the federal labs compete with each other, we also collaborate. And collaboration is the highest form of competition when you begin to look at our rivals like China. What's happening here is the labs do the research, help create the applications that leads to the innovation. And that creates jobs. It's great for business. It creates affordability for our citizens, and ultimately creates security for our cities, our states, and our country. This is what we're talking about right here, and that collaboration, which includes New Mexico and Colorado, is what this country does better than any place else in the world. So I am honored to be here, excited to be here, and looking forward to being able to, look back 20 years from now and say, wow, I was there at that moment.
One of the things that really helped attract Pacific Fusion to New Mexico was the incredible support from the executive branch of the government here. Speaking on behalf of the executive branch of New Mexico, we have Lieutenant Governor Howie Morales.
Well, good morning. What a wonderful crowd. Just for a moment, I'd like for you just to take a deep breath and look at the beautiful scenery we have behind us and the potential, the clear skies, the beautiful opportunities we have in the state of New Mexico, and it is truly breathtaking. And I'm excited to be here with each one of you on behalf of Governor Michelle Lujan Grisham, our entire cabinet, and the people of the state of New Mexico. Felicidades. In New Mexico, we have many reasons to celebrate. In our culture, we talk about felicidades, celebration, opportunities to recognize, and that is exactly what we are doing today, is recognizing the potential that we have. Just last week, I had the opportunity to host the Aerospace Space Association National Conference here in New Mexico, where we had industry leaders from aerospace, aviation, scientists from all over the country that came into New Mexico, and it gave us the opportunity to truly showcase what oftentimes we don't even give ourselves enough credit for. But when we have the labs, our university systems that are working together, the opportunities that we have with our Air Force Research Laboratory, it truly shows that New Mexico believes in science. New Mexico believes in innovation and applies it. And New Mexico believes in a clean energy opportunity that today represents. But a lot of this that goes into work didn't happen just by chance. It happened by deliberate acts of vision that many people here demonstrated. I can remember being there in the legislature as lieutenant governor and having discussions with legislators like Michael Padilla and Meredith Dixon, who carried legislation to make sure that we were going to see this from paper to reality to groundbreaking. So as we are in your Senate District, Senator Padilla, I want to give a big round of applause to you for all the work that you have done. And Representative Meredith Dixon, please give him a big round of applause. Thank you. And I'd also like to take a moment as a former legislator as well. I always recognize and respect the legislative body and the work that they do. If I can have every legislator who is here with us today, please stand and be recognized for all the work you've done to make this possible. And what a wonderful opportunity for Felicidades. And when I say that, I truly mean that. Because when we have the potential that we're seeing right here in the state of New Mexico, where we see the over $1 billion investment that's been done that provides permanent 200 jobs, and already 70 jobs in place in the Las Lunas areas, where 95% of those jobs are taken by New Mexicans. Those are reasons why we celebrate. And as just the mayor was talking about, was a beautiful example of why we do the things that we do. And when we talk about the need for economic development, and I think that there's always a time and a place to have discussions for economic development, whether it's trading off with tax incentives, whether it's land that's exchanged, whether it's discussion with water. There's always a place to have that discussion. But what I'm most grateful for is this truly represents an opportunity not only for economic development, but more importantly for economic gardening. And economic gardening is the investment right back in the state of New Mexico, where we grow from within and we develop that garden that we are seeing behind us. And as you heard from the senator, as you heard from the mayor, as you'll hear from President of PNM, Don Terry, myself, Senator Padilla, and many others who have chosen to stay here, born, raised, educated in New Mexico, because we believe in that. And the story goes on for many of you who are here too. And it truly is the opportunity for investment, for economic gardening. And when I look around and I see what this truly means, I would like to ask my colleagues right here in the second row, all of our young people in attendance, if you'll please stand. This is the reason why we do what we do. This is the reason why we're investing in the present and one hand in the future. So congratulations, Pacific Fusion. Thank you for your investment and your belief in seeing that New Mexico is committed. And felicidades to all of you. Thank you.
The Fusion mission is ultimately about power, clean, abundant electricity on the grid. That makes the local utility another critical partner for both powering the demonstration system in the near term and looking to generating power in the future. We are so thrilled to have the president and CEO of PNM, New Mexico's largest electricity provider, here with us today. Please join me in welcoming Don Terry.
Good morning. I looked at the lineup and was humbled and an opportunity to speak with innovators as well as people that care about New Mexico, and that's super exciting at this time. I noticed I followed all the great speaking politicians, so I don't know about that, but we'll go with it, absolutely. Excited about Pacific Fusion being in New Mexico. What a great opportunity it is. Just a little bit about PNM and our journey and why Pacific Fusion and that kind of technology could really benefit us as the utility sector, as well as our customers as we kind of go forward. You know, one of our number one priorities, it is our number one priority, is to provide reliable, affordable, clean energy. You know, as we look at last year, we were 99.9% on the reliability front, which we were extremely excited about. Our bills are well below the regional and national average. And our journey to clean energy started in 2019 when we were 29% clean. Today, we're 80% clean. That's driving renewables, battery storage, as well as wind as we kind of go forward. So excited about that, but I can tell you the next 20% gets very complicated as we manage the grid. And excited about the technology that comes. We embrace innovative technology and the opportunities that it brings. In the utility sector over the last 24 months, we've seen a great increase in the demand, far greater than my 30-year career of the demand happening across. And it's the discussion when you get with CEOs of utilities that they talk about, how are you going to meet that demand and how are you going to meet that demand reliable, affordable, and clean as you kind of move forward. And so as you think about the announcement today, innovation's happening all over the globe. But what makes me more excited than anything is this innovation. We don't have to travel all over the globe. It's happening here today with Pacific Fusion. And that brings excitement. You know, for being a kid that grew up in New Mexico, one of my key objectives is how do we keep our kids' kids here in New Mexico? And that's through economic development. That's through driving the opportunities that exist with the beautiful sky and the opportunities that we have. And so excited and welcome Pacific Fusion. We're excited to partner with you and look at opportunities. And thank you very much.
It is a critical moment in the history of fusion. It's a global race to achieve fusion energy, to reach high yield and high gain fusion, and ultimately put fusion on the grid. High yield fusion also has implications for science relevant to national defense. And we are so honored to be joined today by Undersecretary for Nuclear Security and Administrator of the National Nuclear Security Administration, Brandon Williams.
Thank you very much. I'm honored to be here and representing the Department of Energy. The Department of Energy is led by Secretary Chris Wright, who began his career doing research in fusion. You could not have a better leader at the head of the Department of Energy to support moments like this than what we have in this administration. Now, I represent the NNSA. We're about 70% of the budget of the Department of Energy. Let me just tell you, the NNSA is not sending anybody to Mars, and we're not reading your text messages. Okay, for those in the know, you know what I'm talking about. NNSA is not widely known because we are the sons and daughters of the Manhattan Project. And so much of that activity, of course, takes place right here in the great state of New Mexico, by the way, where my parents are from. So, NNSA is the convergence of national security and atomic science. And that's really what this project represents today. I'm honored to be joined by two of our lab directors that you'll hear from, Laura McGill from Sandia and Tom Mason from Los Alamos. Just a few miles from here is what now can be considered the prototype of the Pacific Fusion device, the Z machine. And the United States government has for decades invested in this kind of technology. And all of that's happened right here at Sandia National Lab. Remarkable innovation to keep our nuclear stockpiles safe. And so one of the takeaways today is not only the public-private partnership that we're going to commemorate with Keith here in just a second, but it's the foundation of investment from our national labs and our federal government that makes today possible. The scale of the Pacific Fusion project is what is remarkable, but it is being built on decades of leading technology and billions of dollars of investment by our federal government. And we're very proud to be a part of that. But this is what public-private partnership looks like. Decades of investment being married with this innovation. It's exactly what Senator Lujan said. This is for America. So what is the, Keith, come on up. And what is Keith getting out of this? What is Pacific Fusion? Well, NNSA has 70,000 employees and contractors. We're well known for our leading labs, Sandia, Livermore, and Los Alamos, as well as the Nevada test site, et cetera. But what are the American taxpayers getting in this partnership with Pacific Fusion? We're getting what Senator McCormick said, all of the excitement, enthusiasm, and capability and innovation of the private enterprise. And that is what today makes today so special. I guess I thought I timed out here. So Keith, come on up, and we're going to sign this memorandum of understanding. I don't know, what should you go first? Give me a second to back out. Sure. No, go ahead. Go ahead. Thanks again for letting us be part of this special day.
Thank you, Undersecretary. You did a fantastic job pointing to the important role of Sandia National Labs and the Z Machine in particular, just a few miles away, in setting the foundation for what Pacific Fusion is doing today. It's really true that we wouldn't be here without Sandia National Labs, and the demonstration system is an attempt to stand on the shoulders of giants who are at Sandia. So please join me in welcoming Director of Sandia National Labs, Laura McGill.
All right, good morning. It is such a pleasure to be here. We've moved so quickly from just a little while ago when we heard about the vision and the plans for this facility, and we really compliment Keith and Eric with how quickly the Pacific Fusion team has moved to create this opportunity for the Albuquerque community as well as the state of New Mexico. So as you heard, Sandia has been developing pulse power technology for almost 60 years. It's a field of science that allows us to take what is the only capability to try and deliver what happens in the sun onto the planet Earth to be able to replicate those environments. At Sandia Z Machine, we use these capabilities to conduct experiments that help us to understand how materials respond to the highest pressure and temperature environments you can imagine when we store up the energy and release it in a billionth of a second on a small target to understand how the material will respond and to help to build our simulations and our models, which is absolutely key to our role in building confidence in the nuclear deterrent and to protect our nation. We couldn't do that without facilities like this, and the science that's behind it is what powers our ability to do that. For decades, we've been looking at that capability for pulse power technology and how we might apply it to fusion to get a better understanding of the physics and how that could ultimately deliver what Pacific's vision is today and what they're going to deliver for us in the terms of high yield fusion and net facility gain. It's a tremendous, huge opportunity, and they're actually making it real. And what I especially admire it, coming from the national lab that is the premier lab for engineering, we focus on the science and the engineering together. That's the problems that Pacific Fusion is solving, bringing together both the science, but putting that into engineering reality. Because that's what engineers do. We translate the promise of science and technology, we translate that into capabilities that serve communities like Albuquerque in the state of New Mexico. These are challenging goals, though. And it's because it takes so much work and so much science and engineering to put it together. But I really think Albuquerque is the place to do this with the investment that we've had from the state government, from the local community. Albuquerque has been certainly sponsoring this, allowing us to build these public-private partnerships and help to realize what we apply to the nuclear deterrent, but make it available in a way that is going to be the most economical and efficient way that's possible to deliver fusion energy for the community. We're going to continue to do what we've been doing for decades, advancing the pulse power technology, operating our Z Machine, but working closely with Pacific Fusion and the opportunities they have to translate this into a real capability that will help our generations. And as somebody who does consume a lot of power, I can't wait to get that power on the grid for us to use for more experiments at Sandia. So today's groundbreaking is a real important marker of the capability of New Mexico, the capability of science and engineering coming together, and the ability of the national labs working with government, private sector capabilities to be able to make this vision real. We congratulate the Pacific Fusion team and what they're accomplishing, and we look forward to seeing those milestones when we actually have a facility that's putting that power on the grid. Thank you.
Mexico is very special to be home not just to one world-class laboratory, but two. Los Alamos National Lab has been a bastion of excellence in the high energy density science that's relevant for Pacific Fusion's demonstration system, dating all the way back to the Manhattan Project days. So it's a tremendous honor to introduce Laboratory Director of Los Alamos National Lab, Tom Mason.
Well, thank you. It's great to be here, and as Administrator Williams mentioned and was alluded to here, we are the descendants of the Manhattan Project, and in fact, the idea of fusion was very much explored during that time, about 100 miles north of here on the Hill. There was active discussion of the ideas about how we could release energy with fusion. But when the scientists working on it realized that the only way to achieve that energy release was to first set off a fission bomb, they decided, well, let's figure out the fission bomb first, and then later we'll tackle the fusion problem. And in fact, they did in the 40s with the greenhouse series of tests, and in the 50s with the Ivy Mike test. That was mastered. And the idea of using fission to create the conditions that would allow fusion to occur has been the backbone of our nuclear deterrent ever since. And that's the reason why these labs, Livermore, Los Alamos, and Sandia, have continued to invest in this technology. However, for generating electricity, the requirement to set off a fission bomb is a bit of an impediment. And it's taken a while to find approaches that would allow us in a more controlled way, appropriate for electricity generation, to create those magical conditions. And that's the realization that we're here to celebrate. So there's been a progression. We first saw net energy gain in the weapons environment in the 40s and 50s. I'm sure Mark will talk about a different form of net energy gain in a more controlled environment at the NIF facility. And of course, what you heard today is an even more important metric of net facility gain, total energy in to fusion energy out. And the real objective is net wall plug power gain, total electrical energy out to electrical energy in. And that's what this important facility will be a milestone on the path to. But we've also been talking about economic development. And of course, whenever you talk about economic development, people like to refer to Silicon Valley. That is the American ideal of economic development. Of course, Pacific Fusion also has roots there, as do our colleagues in Livermore. But you know, Silicon Valley has principally been famous over many, many years for innovation in the IT and software sector. And to be honest, although that's incredibly impressive and important economically, this stuff is way harder. Fusion is hard. Fission is hard. In fact, just across the street, there's a facility named Kairos that's looking at advanced fission reactors and actually is also working with the labs. And I'd like to think that when the private sector is trying to do really, really hard things, this is where they come. Why do they come here? Because Sandia is just down the road with Z-Machine, because Los Alamos is just up the hill. And I think learning how we can work together to advance the important objectives of these private companies that are going to create wealth, they're going to create clean energy, they're going to create reliable baseload electrical capacity, but also feed back the results of their innovation into our important national security missions. That's a high calling, and geography matters. So I think this is the place that you need to come when you're going to do things that are really hard. Thank you.
Awesome, thank you. In the roadmap to commercial fusion energy, the entire field owes a tremendous debt to Lawrence Livermore National Laboratory, which was the first to achieve ignition in the laboratory. We are so pleased to be joined today by Associate Director of Weapons Physics and Design, Mark Herman.
Thanks so much, and thank you to Pacific Fusion for inviting us to be Livermore to be a part of this really exciting event. One thing I wanted to just spend a few moments on is some of the challenges we face as a nation. At Livermore, one of our responsibilities is to help ensure the nation can design, certify, and assess our nuclear deterrent. And unfortunately, we live in a world where that's even more important today than it has been over the last few decades. And so we sustain confidence in that active stockpile that's deployed today. It's aging. We have to keep a close eye on that. And we support the ongoing stockpile modernization programs that are in production and are working to develop the future deterrent. So what does that have to do with Pacific Fusion? Well, high energy density science is absolutely essential. I better keep that, otherwise I'll just ramble. Is absolutely essential to how we sustain the deterrent. Livermore makes extensive use of experiments at NIF and Z, including fusion ignition at NIF, which was something we worked for a long time to achieve. And that helps us underwrite confidence in the U.S. deterrent. HED experiments have helped transform our understanding of our long underground test history and also helped us make changes to the stockpile, including things like support new manufacturing, new materials, and new designs. And we spent decades pursuing fusion ignition, as Leland mentioned, and eventually, in December of 2022, we got there and have proceeded to do it 11 times since then. That's been an absolutely game-changing capability for our stockpile modernization programs. We're applying it to the stockpile modernization programs. But it also helped light a fire, helped contribute to the fire that was already burning in the private fusion industry. And so we're very proud of that contribution. And together, these advances have helped us move from a kind of a stewardship era for the deterrent to a production era. Pacific Fusion has an important role to play in the future of that deterrent. It's pursuing an exciting approach to extending high energy density conditions to those beyond what we can reach today, and with an ambitious goal of achieving higher fusion yields than we can achieve on NIF or any other facility. So building on the foundational work and inventions from NNSA and the national laboratories, Pacific Fusion is pushing us into new territory and advancing the state of the art. Today's groundbreaking marks the start of an exciting new era for high energy density science. We are proud to collaborate with Pacific Fusion through cooperative research and development agreements and partner with them on moving pulse power architectures forward to help us explore these new regimes. It's a really important example of public-private partnerships. The laboratories contribute mission expertise, scientific knowledge, and trusted capabilities. And the private sector brings investment, engineering focus, and speed. Unbelievable speed. It's just amazing to see how quickly Pacific Fusion has moved. And together, these efforts can expand the nation's overall capabilities at a time when we are in a global race to maintain that leadership. Leadership, of course, for our national security, but also leadership for our economic security. And the national laboratories and our partnerships with private industry are absolutely essential to that. So we're very excited to be part of Pacific Fusion's journey as it works towards its vision of powering a prosperous planet. It's a great tagline. And we really want to give our congratulations on this groundbreaking and on this important investment in Albuquerque and the nation. And we look forward to continuing and growing our partnership with Pacific Fusion going forward.
Let's hear it again for our speakers this morning. It's absolutely humbling to hear such endorsements of support, and with this level of encouragement from so many people, it's really a responsibility on us at Pacific Fusion to deliver on this. So we're going to be breaking shortly to take photos, put shovels in the ground, and commemorate this occasion. Again, speakers, please hang tight and we'll take photographs together. We'll coordinate. Meanwhile, we'll reconvene at 11 o'clock to kick off our Fusion Summit. The Fusion Summit will take place in 2 panels. We'll have Fusion for Energy featuring Senator Martin Heinrich and Eric Schmidt. And then following that, we'll have a Fusion for Defense panel featuring our NNSA and National Lab guests, as well as Keith Lachine again. So please come back at 11. Otherwise, please enjoy some beverages and refreshments, and we'll see you again soon. Thanks for the attention.
Hello. Hi, everybody. Just a quick note for our invited speakers and guests in the front. We're going to start photos at the groundbreaking site with our founders. No luck. Let's see. Yes. If you're near the front and you're in the photos, please stay near the front and we'll bring you over to the site. Stay in the shade, enjoy yourself up here, and we'll come get you. Thank you.
just stroll, man. It's you and me. We made Fusion happen.
I know.
Got a lot more speakers to have shot.
Doing the dig, yeah.
I think she's probably waiting over by the area.
Yeah, well, they were just hiding in this yeah, sounds good. 80% of the work. I know.
Check 1 2 1 2 1 2 1 2. Check 1 2.
Good to see you. Thanks.
Okay, everyone, if you could make your way to your seats, this is your 5-minute warning before we begin the Fusion Summit. So please find your way to your seats. Gonna have the panelists come take their seats. Eric Schmidt, Senator Heinrich, Eric Lander, please come take your seats. Thank you. And everyone else who's mingling, if you guys could take your seats, we're about to get started. Yep. I suspect he might be in the tent or something. So there he goes. There he is. Okay. Panelists, please come on up to the stage. And one at a time. Okay, great. We're lucky to have today two fantastic panels to talk about multiple important applications of fusion energy. First, we have a panel on fusion for energy, and next, we'll have a panel on fusion for defense. For our Fusion for Energy panel, we're very lucky to be joined by Eric Schmidt, a Pacific Fusion board member and chair of the Special Competitive Projects Committee, Studies Projects, apologies, and U.S. Senator Martin Heinrich. The panel will be moderated by Eric Lander. And first, to frame the conversation, I'd like to introduce Spencer Silverman, Chief of Staff and Senior Advisor to the Department of Energy Advanced Research Projects Agency for Energy.
Well, good morning. What an exciting day. I want to thank the Pacific Fusion team for hosting us all here today, and after coming back in from outside for about 30 minutes for the air conditioning as well. But before we get into the panels, I want to spend a few minutes on why today is so important to ARPA-E. For those of you who don't know, ARPA-E is the Advanced Research Projects Agency Energy. We are the Department of Energy's high-risk, high-reward technology agency. Our job is to work with brilliant, daring innovators like those here today to develop energy technologies that are too early or too risky for private capital. For a long time, the national conversation about fusion focused on how far away it was. The technology was still years away. The challenges were immense. All of you know the running joke. Every year for the past 50 years, fusion has been 30 years away. But what we saw this morning proves that creativity, perseverance, ingenuity can transform a distant promise into groundbreaking opportunity. This is what momentum looks like. We are watching fusion taking physical form in real time, standing up instead of just being an idea in a report. We are watching a brand new energy industry move from talking about what might be possible to building it right here in America. Over the past 12 years, ARPA-E has worked with teams to help build a commercial fusion industry. Historically, ARPA-E has invested $134 million in fusion. The technologies we've supported have gone on to attract $1.5 billion in private follow-on funding. That's the kind of leverage public investment can create. And we're not done yet. Under President Trump and Secretary Wright, ARPA-E is doubling down on fusion. This past spring, ARPA-E committed another $135 million to fusion, the largest single commitment in the agency's history. Over the remaining 14 months of the initiative, we are deploying those funds to create even more opportunities for exactly what we're seeing here today: more teams, more technologies, and a move towards viable commercial fusion. Our initial set of investments helped create the fusion ecosystem. When we first entered the technical space, there were about 12 private fusion companies. Today, there are upwards of 50 private fusion companies with over $10 billion in private investment behind them, often spun out from ARPA-E research or technology. Today, an ecosystem exists that creates new connections, new partnerships, and new opportunities to move fusion technology forward. And that ecosystem extends well beyond the individual projects ARPA-E funds. I'm going to put Will Regan on the spot, but he's a great example. Pacific Fusion is not an ARPA-E award, but Will is a former ARPA-E fellow. What he and his team are building today demonstrates that ARPA-E's impact is measured not only by the projects we fund, but by the people we foster and the innovation ecosystem they go on to build. Fusion is the biggest swing of technology we've ever backed. And that brings us to an important question. Why now? Because America has extraordinary opportunity in front of us. We have concrete energy needs, and we must ensure affordable, reliable, secure energy for all. We have the scientific talent, the entrepreneurs, the investors, the national laboratories, and the industrial capacity to turn fusion from a scientific achievement into an American industry. The challenge now is to move with urgency, to build, test, learn, and scale. We don't want to follow the field, we need to lead it. Under President Trump, you can see this leadership across the federal government, across the Department of Energy, and across ARPA-E. So as we hear the great discussions to come today, I want to encourage you to keep this need for momentum and American leadership in mind. This isn't a story about what has already been achieved. It's a story about the achievements still ahead of us. It's a story about momentum. You have private capital moving, you have public investment moving with it. You have the capabilities of DOE program offices, NNSA, and the national laboratories leading the way. And you have a fusion ecosystem creating more opportunities to demonstrate what works and determine what comes next. That's how we give ourselves the ability to win in fusion, not through any single site or any single check, but having an ecosystem firing on all fronts at once. And that is the significance of this morning. We are no longer talking about whether America is going to build the future of fusion. We are watching American companies, investors, researchers, and government institutions make the decisions that will build the future. Thank you.
Thank you, Spencer. Next, to finish framing the conversation, I'm pleased to introduce Matthew Lenkto, the Acting Research Division Director and Program Manager for the Department of Energy, Office of Fusion Energy Sciences. Welcome, Matt.
Great. Good morning, everyone. It's really my pleasure to be here. I'm Matthew Lenkto in the Office of Science. And in the Fusion Energy Sciences program, we are an $800 million per year program developing the science and technology underpinnings for fusion and supporting a competitive fusion industry here in the US. So it's very exciting to see the developments here today. Just this year, the Fusion Industry Association put out a report reporting on over $14 billion invested in fusion from the private sector. And half of the world's fusion companies are here in the US, including all 5 companies funded at the billion-dollar level, including Pacific Fusion. So very exciting time for fusion. And the funding is important, but it's not the full story, right? The actual progress is measured in terms of building capabilities, what we can build, what we can learn, what are the questions we can answer. And New Mexico is really a fitting place for today's celebration. As my colleagues explained, that for generations, scientists and engineers have been building capabilities in these areas. And Pacific Fusion will build on that alongside other private sector companies. And it's very much aligned with the mission of the DOE. And today's the U.S. really taking another important step in realizing that vision in the form of private-public partnerships, which are really at the core of the recent department's Fusion Science and Technology Roadmap, where we identified the hardest barriers to fusion and came up with a roadmap to overcome them. This is a very comprehensive plan. It is based on addressing the scientific challenges, the engineering challenges. It is broad in terms of approach. And at the moment, we are very much reassessing the focus within the Office of Science programs to try and greatly support as many concepts as possible. So I really look forward to Pacific Fusion building this new infrastructure, which is a critical part of answering the harder questions. And we want to congratulate everyone here today on their achievements. We look forward to seeing what is built, discovering what is learned, and working with you all increasingly to bring fusion to the grid. Thank you very much.
Thank you very much. So to moderate our discussion today, I'm very pleased to introduce Pacific Fusion's co-founder and CEO, Eric Lander. Fusion is not the first dauntingly hard challenge Eric Lander has taken on in his career. He's well known for being the founding director of the Broad Institute of MIT and Harvard, and for his leadership in the Human Genome Project. His scientific contributions have shaped the field in biology for 2 decades now, and we are so thrilled to have his skills and expertise on board as we chase this important objective. And Eric, I'll allow you to introduce the panel and lead the conversation.
Thank you, Lee. So we were just standing outside with the shovels, beginning to lay the foundation for a research and manufacturing campus, for a demonstration system that's aimed at producing net facility gain, never been done before. But I gotta say, the real foundations for this were laid quite some time ago. They were laid by the national labs, the work at Sandia and Livermore and Los Alamos, NIF and Z and all sorts of physics. And we would not be here today without all of that work being done by the United States government that has had the vision to pursue that for decades. And we still need a lot more of it. So I want to say thank you to the labs and the DOE and all the people in the government who have had this vision. And we also wouldn't be here today without the state of New Mexico. And I mostly mean almost everybody in the state of New Mexico, because we've interacted with so many people in the state of New Mexico, from the offices of the governor and the executive agencies to the state legislature to the city of Albuquerque and the mayor and I mean, it's just been incredible to watch a state that is able, across parties, to work together to get things done. It has been a real pleasure, and I'm serious. We would not be here today but for what the state of New Mexico has built in such a welcoming environment and supportive partnership with new technology. So before we get into our discussion, I just really want to talk about what the real foundations are. Now, I'm incredibly excited to have 2 people on this panel who are so central to these conversations. Senator Martin Heinrich, 14 years serving the state of New Mexico as senator, ranking member of Energy and Natural Resources, and a champion of natural resources. I know you like hunting, I know you like the environment, I know you like many other natural resources like clean energy. And you've been an incredible champion for clean energy. of many sorts, and in particular, you're a co-founder of the Senate Fusion Caucus. You are the current chair of the Senate Fusion Caucus. You've supported tech transfer from the labs, public-private partnerships. It's hard to think of somebody in the United States Senate who is more appropriate to this very moment right now. So I'm glad to have you here. And just to his right, we have Eric Schmidt, a visionary leader in technology. Everybody in the world knows him for his 20 years at Google. And if they don't know him, they could Google him. Where as CEO and as executive chair, he really produced with a bunch of remarkable people, but with his incredible leadership, one of the most transformative companies in the history of the world. He's also been a leader in public policy who's thought hard about many, many questions facing the government. I've had the pleasure over the years to work with Eric, both in the Obama administration and the first Trump administration, on public policy questions ranging all over the map, including the Defense Innovation Board and President's Council Advisors on Science and Technology. And we're enormously grateful and enormously lucky that Eric Schmidt agreed to be one of the board members of Pacific Fusion. And we would not have a company without the advice and the support and the guidance that Eric has given us. So that's the panel. What's the topic? The topic is, where's it all going? So the first thing I want to ask you guys, and maybe you guys will jump in. We're not going to be very formal about this. Prosperity has been built on the foundation of affordable energy. What's the next 25 years going to look like for the United States, for the world, the uses that we're going to have, the challenges that we're going to have, what we're going to have to do? So maybe, Eric, I know you're thinking a lot about this. We'll turn to you, and then we'll turn to the senator maybe about some of the things that have to be done about it. Yeah.
By the way, we've been close, the three of us have been close friends for a decade. So hopefully we won't repeat each other too much. You know, the story of what we're doing now is the great American story. So what happens is you've got a smart federal government. They do long-term research. They really sweat the details. And this physics stuff is hard. It's hard, and it's not getting easier. And then the entrepreneurs show up. Our financing world can actually finance these things. We're talking about billions and billions of private capital in all those startups with no certainty of return. This does not occur anywhere else in the world. It is a uniquely American experience. The senator and his colleagues have been, and it's a very much a bipartisan support for this, for abundant and hopefully clean energy. My primary focus is on AI, and what I'm trying to do is to make sure that America wins the intelligence race. And the intelligence race is important to win because it will, for your children and grandchildren, it will be how they work. It will be how the great next discoveries occur and so forth. And we've got a serious problem. The cost of the current neural network architectures, chips and so forth, everybody knows what I'm talking about, the electricity cost is forecast to become 11% of American electricity by 2030. Now, there's no scenario, even with all the incredible people here in the room and the financing, that you can get that money in the grid and so forth. So we have to build our own power systems. They need to be in rural areas, and we need to build these big data centers. I'm sorry if you don't like them. Put them in places where there's not a lot of people and connect them, and America wins. Fusion is a key component of that because it solves the political problems on both sides. It's clean and it's abundant. It lowers the cost of energy and it's baseload. So from my perspective, looking in 25 years from now, if the majority of electricity is generated from fusion in America, it solves like all the problems. Now, it's a lot of work to get there. And furthermore, in case you're a total skeptic, this will generate an enormous number of jobs. Just think of the number of electricians, the number of high-skilled workers. These are American jobs. This technology is built in the United States. And I'm very, very proud of this. Senator?
I think we're at a moment too where fusion is moving from one phase to another phase, and it's moving from sort of the physics experiment that has been going on for a really long time at our national laboratories to an era of engineering and implementation, and that's really, really exciting. And you see that in the buzz that it's now generating with my colleagues. 5-10 years ago, most of my colleagues were not tracking anything in the fusion space. I just saw my colleague, Senator Hickenlooper here from Colorado. Do you know how hard it is to get a sitting senator to a different state during the August break? I mean, that's an indication of just how exciting this space is right now. And we've got a lot of milestones to go, but the potential here is enormous. It's always been that last 20% of generation in a clean grid that is the hardest to solve for. And fusion is a critical piece of how we make that happen. But we also need to get there first, because this is an enormous, probably century relevant opportunity for energy diplomacy worldwide, as well as for clean energy generation and making sure that we have the power to meet the incredible increase we're seeing in demand on the electric grid right now.
And I think the other comment, and Senator, you know this very well because you've been leading it, is America needs to invent this ahead of China. They're not slow. So it's very important that the West lead in this technology, that we do this with our Western partners in the ways that you know.
100%, and set the standard for the rest of the world.
So China, you've raised it. They are very serious, but the U.S. government has a lot of levers that we have historically been able to use when we want to drive that partnership between government and industry and academia and national labs. Senator, I'm particularly curious, what sorts of investments, what sorts of vehicles do you see the government making use of in the coming years to make sure that, I mean, China is going to put a lot of money in, but we have a very different system, and I'm curious what your thoughts are about what we can do to make sure that we stay ahead.
I think we need to make sure that fusion isn't just one silo at the DOE, that it is a problem and an engineering problem that all of the government apparatus that we have created over the last half century is relevant to. The government piece of all this that no one can replicate is the deep research and development. And the physics piece of that has been going on for a very long time. But I also think we need to focus that on things like solving for the materials challenges that we're going to have to be able to operate in this very incredible environment that fusion demands. All of those sorts of engineering problems, our labs are unique in what they can bring to that. And then our ecosystem and our private sector is unique too. We have a finance system that is not like any other on the face of the planet. China does not have that. So it's that combination of factors. It's our culture of innovation. There are just a number of things that we can bring to the table that, as much as China can throw resources at this problem, we have a unique toolbox and set of tools that we can apply to it, and we just need the will and the financing, making sure that we continue to support these things through our appropriations process. We need to bring all of those things to bear, and I believe that we will be successful in not only being first, but setting the standards for the planet.
And at a time when maybe not everything is bipartisan, what's your sense
You've
about...
noticed that?
I don't want to go out on a limb, but it seems like that might be the case. What's your sense about support across parties? Is this the sort of thing that can sustain across administrations?
Absolutely. And different different political flavors have different reasons for being supportive of fusion, but it has been very bipartisan in both the House and the Senate. Some of that has to do with the geography, frankly, of the national laboratories too, and we need to maintain that. I mean, this is so important for our leadership in the world that we can't allow it to fall victim to another partisan food fight.
If I were to frame it, I would think of the following. The Chinese strategy is basically they identify a national champion and they fund an enormous amount of funds into it, billions and billions of dollar equivalents. Our system is different. As we discussed, the government does the initial research. We have the smartest physicists in the world sitting in Sandia up there and in Los Alamos. I know because in my military work, I was working with them, and they're like stellar. Excuse the pun. And in the American system, you have to get the money out of the private sector, which is coming because of the scale. This is $1 trillion industry. And just think of the returns, think of the financing. But the other thing is the partnership with other countries. So it's the Chinese approach is essentially unitary, whereas my guess is that 25 years from now, you'll see components built in South Korea and in Japan and in America and in Europe and in various other places, maybe even Saudi Arabia, where the designs were done in America and they're done under license and under American control. That ecosystem is one of the strengths of our national security strategy. We are tied together in trying to solve these problems, and everybody wants abundant, inexpensive energy. And if you have not traveled very much, go to a country which has an unreliable power grid and ask them why they don't have any manufacturing. Manufacturing buildings need reliable power, and you can't shut on and off the thing, so forth and so on. So I'm always, whenever I return from those trips, I'm always sort of amazed at what happened in the 50s and 60s and 70s when the extraordinary achievements of the time were rolled through.
So in addition to it not being the most bipartisan of times, it's also a time when I think younger Americans are not always feeling optimistic about the future. And I think you guys are perfect to answer the question. If you were talking to somebody who is 20 years old and coming out into this world and we're looking ahead to the next 25 years, what would you tell them about where we're really going to go? I think people need right now a vision of an optimistic, realistic optimistic vision of where this country can go. And I'm not sure they're getting that. And since I have you both here and you're both very good at this, what would you tell them?
Senator?
I would say that you are living in the most scientifically exciting time in the history of planet Earth, and that the pace of solutions is going to move at a pace that used to take decades and centuries in a matter of months and years. And that as big as our challenges are, that the pace of solutions is going to allow us to meet and exceed those challenges. And so rather than sitting back and, sort of wringing your hands about those challenges, figure out which ones you want to be part of solving and revel in the capacity and the excitement that the current moment in history allows for.
So my answer is I'm extremely jealous of this next generation of 20-year-olds because the field I entered, which was software programming, is no longer exists, right? It's been replaced by artificial intelligence, and the people who were like me are now the architects of what the computers program. The ability for human creativity and reach and scale has advanced at sort of orders of magnitude that are hard to describe. This is because of the digital age, it's because of essentially scale computing, it's because of the energy and all the other work from so many people. So if I think of somebody at that age, what I tell them is start by understanding that new tools have arrived that all of us are incredibly jealous about, and figure out how to use those tools to solve an interesting problem that you care about. And I'm not talking about social media and your reputation. Sorry. What I'm talking about is what is meaning to you? What is your religious concern? What is your cultural concern? What is your technical concern? What problem in human happiness, human flourishing do you want to fix? Solve that problem. These tools are that powerful, and we are 5 or 10% into the evolution of those powers. And one other comment is, so I've been through enough cycles of brutal competition in the tech industry. I actually go back to the PC wars, the PC versus mainframes, Mac versus PC, the internet wars, more recently, the various social media stuff and so forth. This is the most competitive, the most brutal competition that I have ever seen. That competition is, one, uniquely American, and two, benefits every citizen of our country. Let the games begin. That's how amazing this period is going to be.
Here, here. Yeah, I don't get excited about things like apps or chatbots, but I get really excited about things like clean energy at scale or curing cancer. And that's the moment we're in. And to see capital now start to flow into not just a quick return because you can code a new app, but to see capital flow into projects like this, that's an exciting time to be alive.
What does it mean for New Mexico? So we're standing here today, 5 years, 10 years, 15 years from now. What's it going to mean for New Mexico that New Mexico's decided to step up and do this?
It means our kids and grandkids can stay here and dedicate their lives to something meaningful. My oldest son is at UNM. He's studying nanosystems engineering. Like this is New Mexico.
Wow.
We do hard technical things. From the space race, I just came from a groundbreaking or a ribbon cutting for a really exciting space vehicles and satellite company that just fits right into the sort of history of what we have contributed to the world, to our national security and the stability of the world. And this fits into that great history and gives us something to look forward to.
So I know we're supposed to wrap up in a moment, but I want to ask, if I may, from each of you, what advice would you give Pacific Fusion right now? We were founded about 3 years ago, really got off the ground with serious employees about 2.5 years ago. We have a lot still to do. What advice, based on all the things you've seen, would you give the now 260 employees of Pacific Fusion to make sure that we deliver on this mission?
So it would be helpful if the federal government came up with another $10 billion of project financing for all the fusion companies. So, Senator, can you put that in your notes?
So project financing could be long-term loans that get paid back, for example.
And
that would be a really powerful.
The current government has a number of vehicles that would materially help with the financing. It's very difficult to raise for all the companies. I'm not speaking for Pacific Fusion. One of my other jobs is I build data centers. And the position that I've been taking is, this is all fine and dandy, but you've got to meet the competition where it is. So my primary focus at Pacific Fusion, because I don't really understand the physics, to be honest, is getting a scalable business architecture where not only is this thing a historic achievement, which will occur here in New Mexico, but it's also a good business. And your competition are essentially these combined cycle natural gas turbines, about 500 megawatts. They're easily priced. You can easily capture the cost. And my position for Pacific Fusion is that's your competitor, right? It's not the other fusion companies. It's the install base. One of the things that I've learned in energy, and it's true in general in these hard sciences, is that when you invent something new, its scale unit cost is not the same thing as the scale unit cost of something which is 50 years old and has had all of these process improvements. So we Pacific Fusion need to focus on making sure we enter at a reasonable price point, and then with scale, right, prices come down, so forth, jobs get created, and so forth. I personally believe that will occur over a decade starting in 2030, and that will be a very large jobs program, not just for America, but also for our allied countries.
One of the tools that the federal government has to meet the challenge that you started with about project finance is the Loan Programs Office, and I think we need to recognize that we have these tools in the federal toolbox, and make sure that we're deploying them and using them adequately. I would also just say, with respect to advice to Pacific Fusion, think about all of the business cases before your power plant that competes head to head with those combined cycle gas turbines. Like, there are going to be additional business models along the way that are based on the different steps between now and that actual power plant, and maximizing those and building real business models around those is going to be really important to be able to get to the end case.
Yeah, there's a whole bunch of very interesting radioisotopes that this thing can produce. There's also an enormous amount of help that it can provide for our national security, which is another thing that I'm very focused on, and I think Pacific Fusion can do that.
And indeed, we're going to have a follow-up panel on national security, because just as you say, the fundamental core technologies that have made this possible, we pioneered it at Sandia with pulsed power fusion. Those pulsars can do a lot of different things, and they have many missions. And we'll have a panel on that. I feel like I could go on with you guys, but we can't actually go on. And so we'll wrap this panel up. But thank you both for being here and for setting us off on this journey. Thanks.
Thank you so much for this fantastic panel. That was very insightful and interesting and inspiring. We're going to take a 10-minute break, and we'll reconvene at 11:50 for the Fusion for Defense panel. So see you momentarily.
Ding ding.
Okay, everyone, please make your way back to your seats. We'll be getting started in just about 2 minutes here, so please file in. If you'd like to come up and take your seats, that would be great. Final reminder to please take your seats. We're about to get started. Please come on in.
You're fine.
Let's kick off our final event for the day. We're so excited to introduce our Fusion 4 Defense Panel. to explore the implications of high-yield fusion for matters that are relevant to national security. We've heard that it's a global race, and all of us here today, I believe, are united in the expectation that the U.S. should lead in this technology and win the race. Moderating the panel today, we have Abby Remler, advisor to the Special Competitive Studies Project. Previously, she was the director for tech leadership at the SCSP, and she led strategic initiatives across AI, robotics, energy, biotech, and fusion. She was one of the main authors on the SCSP Commission on Scaling Fusion Energy, which is a fascinating report. I really encourage people to read it if they haven't. So I'll turn it over to Abby to introduce our panel and lead the conversation.
Thank you so much, and thank you to my esteemed guests on stage with me today. It's really an honor to be here and celebrate this momentous groundbreaking occasion and to facilitate a conversation among some of the best minds in the country and the world on this intersection of fusion and national security. And I know we've had the opportunity to hear a little bit from each of you already this morning, but what an honor it is to bring that brain power together. And I'm hoping we can use the next 20, 30 minutes or so to think collectively about what a public-private strategy for U.S. leadership at the intersection of fusion and national security looks like. How do we get this right so that it is America writing the rules of the road? So I will introduce these guests that you've heard a little bit from already. We have Brandon Williams, Undersecretary for Nuclear Security and Administrator of the National Nuclear Security Administration. Laura McGill, Laboratories Director at Sandia National Laboratory. Mark Herman, Associate Director for Weapons Physics and Design at Lawrence Livermore National Laboratory. Tom Mason, Lab Director at Los Alamos National Laboratory. And Keith LaChene, co-founder and CTO of Pacific Fusion and formerly of the NNSA and National Lab Enterprise. So we have the Fusion National Security Avengers on stage. And no better group to have a conversation at a really critical moment when the United States is facing a more challenging nuclear security environment with two near-peer rivals, and where China in particular is making major investments at the intersection of fusion and weapons science infrastructure through their state-directed military-civil fusion approach. That includes $10 billion into the talent, the R&D, and the infrastructure for next-generation fusion, and 5 new facilities, at least 3 of which are under construction, one of which is a similar facility to what we're groundbreaking today. So the race is on with the shovels in the ground now. And we're also talking a little bit about what America can do to counter that, because this is a race that we have found ourselves in, and it's one for which we have many advantages for what this next generation of fusion leadership looks like. And many of those advantages are in this room, and they're on stage with me. They're the world-class expertise and exquisite capabilities out of our national laboratories. And it's also the new crop of companies that are building these next-generation facilities in America that could serve both the commercial energy missions that were the impetus for those companies, but could also help serve some of the national security missions that our laboratories work on. And the challenge that I hope we can talk about is how to stitch those advantages together into something like a national strategy for U.S. leadership that's drawing on the successful models America has used in recent history, in the 20th century, and that we see playing out in areas like commercial space, which Keith mentioned earlier. How can we blend that together for inertial confinement fusion and high-yield fusion in particular? So fortunately, we can start with some great news, which is we saw an MOU signed just this morning about how the labs and industry are going to partner with this facility and with the work that Pacific Fusion is doing. So I wanted to start with Administrator Williams and just ask you what this signifies about where we are in public-private partnerships between the national laboratories and industry.
Thank you, Abby. I'm glad to be here. It turns out people often ask me what I do, and I say I run the nuclear weapons program for the United States. and then I don't get invited to anything, particularly not socially. So I'm thrilled, really to be here. But I'm also honored to be with our lab directors, truly, among the greatest leaders, scientific and engineering leaders in the world. And so I'm honored to be a part of this. What you're seeing today in this MOU is an acknowledgement that the foundational work of atomic science is no longer and exclusively the purview of the United States, of a state government, at scale at state. That with the advanced nuclear on the fission side, the nuclear renaissance that we're seeing, we just see a flood of capital and interest flowing into that, but also on fusion. And so it would be reckless for the Department of Energy, for my organization, to proceed without harnessing the great innovation power of the United States economy. And that comes with investment, that comes with risk-taking, that comes with efficiency. I'm sorry to say, lab directors, that we do not quite live up to, as government entities. And so we have to harness that. And that's exactly what you see laid out in our announced partnership today with Keith and his organization.
Thank you. And I'd like to turn to each of our national lab leaders on stage and ask if you could remind the crowd what particular type of fusion your lab works on and how that intersects with the national security mission of your laboratory. And then I'll ask you to do one more thing, which is to mention one way you are already working with the private sector, with industry today on fusion. I'll start with Laura, and then we'll go to Mark and Tom.
Yeah, very, very good. Thank you, Abby. So we've been working in, as I said earlier, on pulse power technology for over 60 years. We use that to really to replicate the extreme environments on Earth that our systems have to be able to withstand. High pressure, high temperature, all with energy released in just like very small time frames. Think billionths of a second. And we use that to understand the high energy density physics that so that we can understand how our materials will respond. And in the end, it gives us confidence in the nuclear deterrent that we can continue to protect the nation as the foundation of the national defense strategy with the nuclear deterrent. But with that, we've been able to build the science behind that. And as we've built those capabilities over the year, and they have evolved, and we've had to take advantage of new technology, and that's actually something that Pacific Fusion is, that's a lot of our partnership is, to the administrator's point, maybe we could be more economical about how we create these facilities going forward and how we continue to build more capability, because we're not done. We have to continue to push the envelopes, just as our adversaries do, to understand this technology, build our models and simulation, and continue to innovate on our systems that we have to deploy for the nation. So it's a great partnership. And I know that we're going to continue to evolve that, and what is developed from Pacific Fusion is going to come back to the labs and pay dividends as we continue to advance these technologies for pulse power technology.
Mark, over to you. And maybe I can also ask you to remind the crowd what Lawrence Livermore achieved in December of 2022.
Sure. Some people think we talk about that a little too much. So we have been pursuing approaches to inertial confinement fusion really from the 1950s. We use both lasers and pulse power to study inertial confinement fusion. Fusion is a fundamental process in our thermonuclear weapons, and so it's very important that we understand it. And the challenging time we've had in getting fusion ignition is in part because our simulations, while very, very good, are not perfect, and we're always stressing them, and fusion is the way we can stress them the most. But it's also exciting because the output of an igniting fusion capsule can create even more extreme environments, far more extreme environments than either a pulse power driver or a laser driver can achieve if you just fire them at a target. If you can get a capsule to ignite, you can create environments much closer to weapons conditions. And we're leveraging that now because on NIF we've achieved ignition 11 times and used it most recently for a very important nuclear survivability experiment that helps us with our weapons modernization program. So we are putting that to use today. NIF has been a long journey, and it has had a tremendous benefited from tremendous private-public partnerships. I saw some folks from General Atomics here. General Atomics has been a long-standing partner. Without them, they build the targets that are absolutely essential to the work we do, both at NIF and Z. So we have that great partnership already. But NNSA has a lot on its plate right now, and it's got a lot to do in stockpile modernization and really reconstituting a production infrastructure. So it doesn't always have all the resources that it would like to have, and the advent of the private capital, private industry infusion right now is coming at a perfect time to help us build on the success of Ignition and extend that. And so that's an opportunity that Pacific Fusion and the other fusion companies looking at inertial fusion approaches are just at the right time for us to have potential to leverage that. So.
Thank you. Tom, over to you.
Well, as Mark has mentioned, understanding fusion in all its complexity and the environments that it creates is central to our core mission. So we pursue these R&D activities because of their relationship to our national security, nuclear deterrence, and the way that scientific understanding informs our understanding of weapons physics. At Los Alamos, we don't operate fusion facilities. We are users of Z. We are users of NIF. In fact, one of those 11 shots was a Los Alamos design shot. So independent, peer review validation, if you will, that it works. And if you mentioned some of the investments that China is making, and I'd like to maybe just drill down on it a little tiny bit. There's actually some interesting publications from RAND by a fellow by the name of Jimmy Goodrich, looking at the investments that the Chinese are making in a facility that looks pretty much like a scaled-up version of NIF and something that looks pretty much like a scaled-up version of Z. In fact, they look very similar to proposals that have been made for Z Next and NIF 2.0. For the same reasons, for the same national security drivers that we have. Now, we're not 100% sure because there's maybe a little less transparency in that system than there is in ours. But, the way that system has worked is they look at what we accomplished, and they say, that's important, we need to do it. We publish roadmaps of what we would like to achieve, and they're going down the path to build them. But it's important to remember they're playing catch-up, right? That laser ignition facility is still under construction 4 years after we achieved ignition at NIF, and my guess is by the time it's up and running and they figure out the physics, which is non-trivial, it could be a decade. And so then the question is, okay, if they're working hard to catch up, what's our strategy to make sure that when we get there, or when they get there, we've moved on? And I think part of our strategy is to take advantage of the unique capacity that exists in our private sector that was talked about in the last panel. And we are certainly very interested at Los Alamos, just as we are users of Z and we are users of NIF, if there are new experimental capabilities that give us access to the regimes that are important for our core mission, and they are achieved through public-private partnerships, then that is, I think, the way that we make sure that by the time ignition is achieved in China or their pulse power machine is working, they're still in our rearview mirror.
And if I could just, before I go to Keith, Tom, what does it mean if China catches up? What are the implications of that?
Well, as I said, they're pursuing these activities for the same reasons that we do, and they're in the midst of a pretty substantial expansion of their nuclear capacity in order to, give them the perceived freedom of action that kind of thing entails. And unfortunately, we live in a world today where nuclear deterrence is as relevant as it has ever been. And I think that condition is likely to persist for a long time. I don't see a quick fix to our geopolitical quandary. And therefore, we cannot slow down. We cannot relent. We have to keep our edge and make sure that we have the technical capability to respond to any development anywhere in the world. Our technical competence is an element of deterrence every bit as important as the on-alert weapons that we're responsible for.
Now, Keith, to round out the first round of questions, I'd like to ask you how your experience working in the national laboratory ecosystem and at NNSA has informed your approach now that you're in the private sector towards public-private partnerships. And with that in mind, what this MOU signed this morning signifies to you.
Thank you. Thank you, Abby. It's a really exciting time. And this administration has been extremely supportive of public-private partnerships and fusion across lots of other areas as well. I think of what we're doing here today, and basically impossible when I was there 10 years ago, and maybe even impossible just a few short years ago. It really has been the achievements by National Labs and many, many technical partners that have contributed to the ignition on NIF, amazing accomplishments at SNE that enabled this moment. When I think about today's MOU and listening to the remarks here, I think this is how we stay ahead, right? Because we want to say, China's going to catch up. The only thing that's going to make that true is if we together make sure that we're first in things like high yield fusion. This is 100+ megajoule outputs. This is not something that our present capabilities can do. They're amazing and we have to sustain them and refurbish them, of course. But we can't get to those high yield regimes without the partnerships that we've laid out here today. There are also many technology advantages to working together. At Pacific Fusion, I think, I haven't counted in a while, but I think 20 to 30% of our staff spent lots of good years in the national labs. And our existing partnerships that we have right now enable those scientists to work together and hit the ground running as we break ground today on this first ever high yield facility. So looking back just a few years wouldn't have been possible. And with this administration and this team here, we're setting a path forward that makes sure that we stay ahead.
And Keith, since you waited so long, I'm going to do one more question for you now, which is, you mentioned earlier on stage commercial space and the NASA COTS model as one that feels particularly relevant and pertinent for fusion. So I'd like to ask you to expand on that and tell me, how do we get from where we are today with something like the MOU to something like a NASA COTS for fusion? What does that look like?
Right. So we all know what SpaceX is. But that's because of a critical moment 20 years ago called the Space Act that set forward a very clear public-private partnership between NASA and a very nascent space industry that had a couple of entrants that were doing some interesting things. By the Congress and the administration again saying, we are going to do this. We're going to take this particular piece of the mission that's really expensive to do. We're going to take this and see what industry can do with it. It put that model into place. It was a milestone-based program, a post-payments program. So it wasn't, let's give this company money and see what they can do. It was, let's set a milestone. If you achieve it, there's a post-payment associated with that. That brings zero risk to the government until that thing that's super important gets, is achieved, right? This is a playbook that we know. It's worked. We now have a commercial space industry. We lead the world. We couldn't have gone on the Artemis mission recently without SpaceX. It has built this entire infrastructure, and look at all the many things and the many conflicts we have today that rely upon being able to basically at will launch capabilities into space, right? We could do that same thing in fusion. We sit here on the front end of the fusion energy, meeting the next couple of decades of demand, as we heard from our previous panel, but also staying far ahead of our adversaries in defense fusion. That public-private partnership playbook, we need to run that. That requires the administration to lead as it is. It requires Congress to work with the administration to put that together. Today, the 2027 NDAA, National Defense Authorization Act, the drafts that are in conference, both include provisions around working together with industry to take advantage of the amazing capabilities that private fusion is building. So it is happening. We're starting to see that corner turn. This MOU really formalizes that.
Absolutely. And with the 4 minutes that I believe we have left, I'd like to do a lightning round for everybody and just ask, what 10 years from now does the world look like if we get this right? What does the ground that we're standing on now look like? Keith, I'll ask you that question. And then for the lab directors, what is the work at the laboratories look like in a decade if we get this moment right? And then Administrator Williams, I'll ask the same of you with one other question if we have time.
Right. A lot is to come, right? Today we put the first shovel in the ground. There's a lot of work to do. We intend to be achieving those high yield milestones by the end of this decade, right, by 2030. That is a big, ambitious goal, and it's going to take our partnerships with the national labs, academia, and other industries to make that happen. Looking into the next decade, we have to commercialize the technology that meets energy growth and demand that we haven't, a scale of which we haven't seen in terms of the rate of growth since World War II. That's a huge challenge, and it starts with these next few years getting it right, and then making sure we, build upon technologies that are mass manufacturable, affordable, practical, and scalable to meet those future energy challenges. But it starts right here today with this great team.
Thank you. Tom?
10 years from now, I don't think our mission is going to fundamentally change. I said, geopolitically, I think we're going to be in this space where we need to be really aggressively pursuing the frontiers of science and engineering. The way we do it is going to be completely different. And, there was a discussion earlier about how artificial intelligence can transform everything, but can certainly transform science. The raw material for artificial intelligence is data. And the experimental data in particular that has not yet been generated, that is not in the models that we see now, is going to come from the kind of facilities that get us into the environments we need to get to. And so I think that's a very exciting future. We're going to be able to do things we can't do now. But as great as AI is, in the absence of the kind of experimental capabilities that ground it in reality, it's not going to be useful. And hopefully this kind of partnership is going to give us access to those experimental regimes.
Mark?
Yeah, just building on that, I do think the thing that will change is the speed at which we have to respond to maintain deterrence. And so we're taking steps towards going faster right now, but data and understanding and uncertainty is one of the things that's a barrier to us going faster, our ability to build things quickly, but also to have confidence in them. And that's where the experimental data is critically important. So we're going to continue to expand the regime over which we can get data. That's going to greatly help us go faster in the future, make sure that our deterrent can continue to adapt at the speed of relevance in a more dangerous world. So that's a key part of that. I think having fusion will underwrite a lot of those developments. Having the ability to access high yield would greatly aid in that speeding in our ability to speed up. And so working with partners in the private fusion industry, pushing NIF and Z as far as we can push them together, I think that's really a recipe for having a strong deterrent, and also, as Tom highlighted, also a very visible sign to the world that we're really good at what we're doing here. So you don't have to question our will or our might, because we're showing it with our prowess. So.
Actually, I'll build on that because we're in a really good place under the leadership of the labs and the Department of Energy. The nuclear security enterprise is delivering. We are increasing our capability to produce. We are doing it faster, and the innovation that's going to be unlocked by these capabilities, a lot of it comes out of the labs directly, but the partnership with the private sector is huge because it allows us to apply this great, science and engineering to new problems in different ways, which is what our people come to work to do. Is a super exciting time, and even if we're going to be, it's going to be hard to keep up with it with all the new developments. We're going to be working with new materials, new capabilities, new processing capabilities, and it's going to be an amazing time to work. But what is great about what we do is that we work on the very hardest problems, and where we can, we transfer that to the private sector, and then we go on to the next hard problem. So what's going to be different is we're going to have new hard problems that we have to solve, but we all have the right people in place to go do that, and we have the mindset of the enterprise and the NNSA that wants to guide us to go be able to do that and really unleash the power of the nation and our science and engineers around the country.
And Administrator Williams, I'll ask the same question of you, but also what is one step that we should take in the next year that we can take to set us on that glide path?
you're going to see why I don't get invited very much.
Leave us with optimism or pessimism.
Well, I tell people that there's a first place prize for deterrence. First place is freedom and prosperity. And there's a second place prize for deterrence. It's called annihilation and subjugation. And you really need to absorb, what's at stake when it comes to the nuclear deterrent. We have not had great power direct conventional wars in over 80 years. Prior to 1945, we had two that had devastating consequences for certainly European and Asian populations. So that's the benefit of the atomic enterprise. Under my leadership, I have directed that we are going to focus on deterrence, urgency, and production. And we are not going to hurl terabytes of data at our adversaries. We are going to build weapons that deter our adversaries, encourage our allies, and protect our homeland. And so the essence of it, just like in the Manhattan Project, is a production mission to make sure that the president always has the right choice to make our adversaries think twice before striking at our critical interests or exploiting some opportunity that they think will give them a strategic advantage. That's the essence of the nuclear deterrence. So one thing I would ask in the next year is that often I refer to the nuclear deterrent like the spare tire in the trunk of our car. Most people forget that it's there. Of course, we pray to God that we never have to use it. And there's a significant number of people that ask, why are we hauling this weight around with us? Get better gas mileage if I didn't have that in the trunk. In the next year, I would ask that American leadership, that the American population wake up to the extraordinary work that has continued under the leadership of these lab directors and the NNSA, and remember the importance and primacy of our nuclear deterrent. It is literally the foundation of our sovereignty. And we're at an inflection point where we need to make generational investments to ensure that that continues for another 80 years of what I would call relative peace, certainly between great powers. Those are difficult truths to swallow. We love being here talking about the future of fusion, and we're excited about that. But the reality is we live with very dangerous adversaries that have very different values and very different objectives that are not compatible with the interest of the United States. And so we need to have a healthy remembrance of that. I'd just say in closing that we are not entering, definitively I'd say we are not entering into an arms race reminiscent of the 50s or 60s, but we are in a capabilities race with our adversaries. And frankly, we are the world champions, they're sitting here to my right, including Keith, in innovation. And that's what today signifies. So I'm very optimistic about the next 10 years. I believe 10 years from now, the United States will be strategically stronger than any time in its history.
What a great place to land. Please join me in thanking our panelists.
Thanks so much, Abby, and to all of our panelists. Thank you to everyone who took the time to come here today. As a Pacific Fusion employee, it's absolutely humbling to hear from so many people advocate for the success of this project in particular and fusion energy in general. So this will conclude our meetings this morning. If you're here in person, please feel free to check out our exhibits or take some photos with the tractors or the dig site. We will be turning off the air conditioning imminently, so you probably won't want to linger especially long. But thank you again for coming and safe travels.